In this presentation, we'll talk about the San Juan Sailboat Charters lab that we recently completed. There's some things that popped up in the lab that I want to talk about so that you are aware of them for the future. So let's take a look. Here's the original data model for the San Juan Sailboat Charters problem, the one that's given to you in the book. Remember that a data model is abstract. When you're asked to take a data model to the design, you're necessarily going to have to add a few details and to iron some things out. One big thing that popped up in this data model is the fact that you have three many-to-many relationships. Here, here, and here. Remember that we cannot represent a many-to-many relationship directly in a relational database management system. What we're going to have to do there is to convert them. We're going to have to convert them using a process that we mentioned before and that the book talks about it a little. We're going to have to add three intersection tables. These intersection tables will sit in between the two related entities, and they will serve to tie those two related entities together. So what we do to convert many to many into something that we can use in a relational database system is we create an intersection table, what I've called in the past an associative entity. The name you would use is really just a matter of when you perform this step, whether it be in the data model phase or the creating a design phase. The many-to-many relationship is replaced with two identifying one-to-many relationships. The many side is on the intersection table, and the one side is on the related table in each case. So you have two one-to-many relationships with the many side for both on the intersection table. The primary keys of the one tables becomes the composite primary key of the intersection table, and these are also foreign keys. Take a moment to read over this because it is something we will see again in the future. Here's another relationship that seemed to give a few people some trouble. Again, a data model is abstract, so some details may be implied rather than explicit. Anytime you have a relationship, there will be a foreign key involved. This is one example, by no means the only one, in this particular data model where a foreign key is required. When you have a one-to-many relationship, you necessarily have a foreign key on the many side, linking you back to the primary key of the one side. Notice here for scheduled maintenance, we do not have a field called Coast Guard registration number. This is not an identification dependency. We have a dashed line indicating the relationship, and it uses a surrogate key called maintenance ID. What we would need to do in the design is we would need to add an additional field here called Coast Guard registration number to scheduled maintenance. This would be a foreign key linking us back to boat. However, it would not be part of the primary key. Here's another example which gave people a few problems. We have a relationship between charter and log, specifically an identification dependency, a one-to-many identifying relationship from charter to log. We can tell that log is related to charter not just by the relationship line and the fact that it's solid, but what makes it identification dependent is the charter ID field, which is part of the composite primary key of log. It's also a foreign key linking us back to charter. In the design step, what we'd have to do is to be explicit in identifying charter ID as not only part of the primary key of log, but also a foreign key back to the primary key of charter. Some other notes that popped up. In this particular model, there were no supertype or subtype relationships. There were none in the original data model, and really there were none to be implied. Part B of your assignment asks you to describe or talk about the weak entities. Using the textbook's coloring scheme, what you'd want to look for in the original data model are the orange entities, specifically log and scheduled maintenance. So you'd want to talk about those being the weak entities and talk about how they're implemented in the design. There, what you'd want to talk about is how one may be an identifying relationship versus the other being a non-identifying relationship, and also talk about the foreign key linkage, which actually establishes the relationship. Part E asks you to identify all foreign keys and to note cascading behavior and such using the template in the book. Please remember that this asks you to identify all foreign keys, including the intersection tables that you will have created in previous steps, and those foreign keys which are implicit in the original data model, like the one on scheduled maintenance linking you back to boat. As far as the cascading behavior, and this goes for the data type creation as well with Part A, the idea there is to use reasoned judgment. Really what we're looking for there is to use your own judgment about whether we would need to cascade deletes and so on. What type of data would these fields actually represent? Most of it can be easily inferred. And there are some that may be a little bit more complex than others, but the idea there is to use your judgment. Some final notes is to remember that a data model is abstract while design is specific. You will necessarily add more details, so you should expect that that will be the case. Finally, ask questions as you have them. I can't stress this enough. If you have questions along the way, do send them to me. Now, going along with that would be the idea to start early. With many of these labs, if you start an hour before it's due, or even a day before it's due, you may be pushing the clock a bit. Be sure to start early. Ask questions as you have them. If I get them in time, I can address them and hopefully help you along the way. But please, ask the questions as you have them, because we will see this material again and we will perform these actions again, including with the team project.